Um, yeah, so I'm so happy to be here with Lois today and all of you. Thank you so much for joining today. We're going to be talking, of course, as you can see, about data science. So throughout the session, we'll be speaking with Lois about her journey into data science and getting an understanding of different specialisms within data science, how they aid business decision making. I know that data science is a huge thing right now. It's been marketed like sort of everywhere. So I think it's great for people to get to understand what data science is, and if they do know what data science is, to sort of get a broad understanding of what it is, or a new perspective, fresh perspective, and also your sort of journey into data science, etc., etc. So just a little bit about Lois. Lois has been able to enable good decision making through data for over 10 years, from data analytics and experimentation through to machine learning models. Ultimately, Lois enjoys working with data and science specialists, engineers, and product teams at Deliveroo to deliver, the best possible in-app experience alongside some great food, of course, which I love. So handing over to Lois to just, yeah, explain to you all her journey and yeah, just things about data science. Thank you. Thank you so much, Lois.
Oh, thank you. Thank you so much for having me. I'm really excited to be here. Um, and yeah, as you said, I'm just going to cover off my journey through data science, how I've ended up uh, where I am at Deliveroo. I'm going to talk at a high level about some of the projects that I've worked on at Deliveroo. And I'm going to start off by explaining what we think of as data science at Deliveroo, and what the different specialisms are within it, with the hope being that might spark some interest in some of you in getting into this industry, and also just to meet some new people, and hopefully link up afterwards on LinkedIn if you do have any interest or more questions. I'm very open to speaking afterwards as well. Cool. So I'm Lois. I've been at Deliveroo for 6 years, just over. And I am what we call a senior data and science manager. So I manage a range of data specialisms, from data analysts through to machine learning engineers and analytics engineers. And I look after science teams that work on our consumer product. So in layman's terms, the Deliveroo app that you would see when you go to order food, which is really exciting. So I absolutely love working on a product that I'm able to see the changes happen in that my team have made. It's really exciting. And before Deliveroo, I was working in a company called Amia that looked after loyalty programs. So I was there for, again, 5 or 6 years. And we worked with lots of different clients to help them better retain and increase the frequency of their customers. Again, really interesting work, but I moved to Deliveroo because I wanted to do more. I wanted to work with product teams, and I wanted to work with clickstream data, and I wanted to do more science. I'd ended up in a business where management was the only progression, and I wanted a bit more time just doing the doing. And prior to that, I was a maths graduate, and I worked in sales for a little bit. I worked in sales right after university. I was absolutely terrible at sales. It was a cold calling job, and I learned pretty quickly that was not for me. So I ended up being reached out to by a recruiter who said, "Have you considered getting into data analytics?" And I honestly hadn't. I hadn't heard much about it. So hoping to spread the word a bit about what that world looks like now. So what even is data science? You must hear the term data science quite a lot. It's been a bit of a buzzword the past few years. The way we describe our team at Deliveroo is our mission is to enable the highest quality human and machine decision making. And we do that by having specialists in 5 different areas. And we actually rebranded our team to be called Data and Science instead of Data Science very recently, because the word data science, quite frankly, didn't fit everything we were doing. It was very specific. There was a group of people that were doing what we would describe as data science. But as you can see here, there are these 4 other disciplines, 4 other specialisms within the team that are doing incredibly valuable work that would not be classed as perhaps science in the purest term. So we have data management professionals, making sure that our data is reliable and fit for purpose. We have analytics engineers who build that data into data sets that our teams can then use to query and to make decisions and to understand trends. We have data analysts who are using analytical methods to determine what's driving performance and uncover opportunities for us. Scientists using inference methods to understand performance of specific things that we do, and then machine learning engineers who are training machines to make decisions with data. I have only ever myself worked in these 3 areas as an analyst, a scientist, or a machine learning, or with machine learning engineers. I've never been a machine learning engineer, but I manage machine learning engineers now. So I'm going to talk about these 3 areas in a little bit more detail today, and I'm going to give you some examples of work that I've done that would fit into these buckets. So an example of a data analyst project would be using market intelligence, for example, to understand Deliveroo's position versus competitors in some of our markets. So that might be to understand how we vary on selection, service, and price versus competitors, and then using that to better our Deliveroo experience in a geographical area. Data science work might be more things like experimentation, so where you're using statistical methods to understand the impact of some intervention that you've made. So perhaps you want to test a new feature in product and you're going to run a test, and a data scientist would be the best person to help you design that experiment. Data scientists here also do work like building models to predict customer lifetime value. So taking data that we currently have and using it to predict what might happen next is also something that data scientists do. And then machine learning engineers at Deliveroo, some of the models that they have built and optimized are things like algorithms that assign orders to riders. When an order comes through on our app, deciding which rider is the best to then deliver that order, deciding how much a restaurant should be prepared to bid for a piece of ad space in product, in order that they're still going to get a good return on investment from that. And another example would be determining the order of the partners that you see on the home feed. So when you first land in the Deliveroo app, there's a model behind there that's looking at your history, your interests, and trying to put the most relevant partners at the top of the feed for you. And then just to add, we also look for people who are well-rounded. So to be a great data specialist, I think you need to show great bias to simplicity. So starting with the simplest solution that you can and taking incremental steps to some bigger vision. Mastering the speed accuracy trade-off. So this is about choosing the most appropriate method for the task at hand. We don't always need to build a really fancy model to answer some questions. Sometimes we can just use some back of the envelope calculations and make a really good approximation of the best action to take. Someone who's flexible as well. So quite often we might have to change our roadmap or our priorities if things change. Something like a pandemic can throw things up in the air as to how relevant Deliveroo is and partners are. So people who are able to kind of lean into that change do really well. And having a curious mindset, just because that makes your job more fun, right? Like if you're curious about your customers and the impact of things that your team is doing, you're more likely to want to look into trends or customer behaviors that then open up new opportunities for those teams. So what kind of problems do we help to solve? I'm now going to talk through 3 different problems that I have been involved with in my time at Deliveroo. I'm going to talk about them at a very high level. I'm not going to go into too much detail. It's just to give you a flavour of what kind of work you could be doing as an analyst, a scientist, or a machine learning engineer. And across all of these problems, the first thing that we would do is to ask questions and to show empathy and to try to understand what our stakeholders, what our business is trying to achieve. So these are some common questions that we might get. How should we measure the impact of this new feature? We're going to add a new button or some new content into our product. How do we know that that's been the right thing for our customers and the right thing for our business? How can we automate decision making? So how can we save people's time in having to make decisions by giving that job to a machine? And when is it appropriate to give that job to a machine? There are lots of considerations when doing that, right? You need to make sure that people are comfortable with it. You need to make sure that your machine is making good decisions. And then a third one we quite often ask, where are our next biggest opportunities? So if we've seen some change in a metric, how important is it that we address that change? Are there ways in which we can improve our business metrics that we haven't even thought about yet, but that we can use data to try and explore? So the first example I'm going to share is one from, this was from about 4 years ago. So please excuse my visuals with this one, they're not that great. But the question was, how can we improve the Deliveroo app for new users? So for people who have never placed a Deliveroo order before, how can we make the experience as good as possible so that we encourage them to place an order and we encourage them to stay with Deliveroo and place more orders? So this is an example of what the funnel looked like for a new user 4 years ago on mobile web. So you would land on the homepage, you would see mostly a picture of a burger, and you would be asked to put in your address further down the page. And on some devices, this part where we're asking for your postcode didn't even appear. You would have to scroll to see it. Then you're hopefully going to enter your location and you're going to see a restaurant list that will tell you, that will show you different restaurants that you could order from at Deliveroo. Then you would get to a menu page. Then you would add products to basket if you like what you see. Then you would be asked to create an account. Before you can actually place that order, you have to sign up. And then you are put through to pay for that order. So to the question of how can we make this better, what might a data analyst do? They might look at what data we have in the background related to these pages and try to understand how people are moving through that funnel at the moment. So this is just an example of some data that we might have. Here I've just used a very basic view, but this tells us for each session whether that person has viewed a homepage or not, whether they've viewed a menu, whether they've then made it through to view a basket and a checkout. And our funnel looked something like this 4 years ago. So if we took everybody that landed on the homepage, only 40% of them made it through to the restaurant list. That's a huge gap, right? 40%. So you think people landing on Deliveroo, you would hope that they've come there with some intent. And you could say some of this gap might be due to bots. Bot traffic happens. That's a very real thing that may be causing some of that drop off. But it seems to us like there's something else going on here that we're not quite capturing correctly. Of that 40% to restaurant list, 68% then make it to a menu, and 35% of those on a menu then add to basket. And then we get down to the registering an account. So once you've added to basket, you've shown quite a lot of intent here, right? Like you've found something that you want to order, you've added to basket. Maybe you're just playing with the app, but likely you've got some intent to purchase. 77% of those would then have registered an account. 73% of those then managed to successfully add a payment method. And then finally, of that last group, 95% managed to become a new customer. So if we look at the drop off here, we ended up having about a 5% conversion rate of people who first ever landed on the app to making an order. Was this good enough? We don't really know. We don't really know how this compares to competitors. But what we can do is we can look at parts in the funnel and we can say, this feels off. This feels like it should be better. And what can we do to improve? So then what you might do as a data analyst is what we call here opportunity sizing, or sometimes we call it like stress testing. To me, it's really about what do you have to believe about improvements throughout that funnel in order to make it worthwhile investing time in developing new features, new products, attracting more customers to that part of the funnel. So what we would do, this is just a rough example here with, I didn't want to put in the actual figures, but hopefully this gives enough of an idea. We'd look at how many new visitors we get to each of these pages. So these opportunities on the left are, we could optimize the homepage to try and improve that drop-off rate to 40%. We could improve the rate of people adding to basket, or we could make it easier for people to sign up. And then what we can do is say, looking at our current conversion rate, what might we then target to improve that by? So here on the first one, I've said, what if we improved that by 1% or 2% or 6% on the last one? And for these targets, what you might do is look at past experiments that you've done and see what feels realistic of a change to achieve through introducing some new feature. And then we're considering, if you believe that you can achieve that target conversion rate, then what does that mean for the number of incremental new customers that you could get? So new customers that you could get over and above what you would naturally expect to have. And then layering on top of that again, what would you expect from those new customers over, say, the span of 12 months? Because a new customer is not just about getting that one order. It's about having somebody love your product enough that they want to come back time and time again. And so this incremental lifetime value is what we really cared about. And what we find is that although it might seem like somewhere like the homepage is going to be the most impactful just from looking at the drop-off rates, actually you can challenge that thinking with this what do you have to believe statement across other parts of the app. So the impact of this project at the time was that we shared all this data, and then we conducted user research. So we went out and spoke to real people who had never used Deliveroo before, and we asked them to go through the flow, and we watched them and we saw what they were struggling with, and that gave us more of the why. We could see what was happening from the data, but user research helps us understand why that's happening and what particular issues people are having as they get through, especially with the sign up flow. And then the further impact was that we created a new product team within Deliveroo to focus on new users. So for at least 2 years, we had a group of people in Deliveroo tech who were focused just on trying to improve that experience for new users and drive more conversions and lifetime value for the business. So on to the second question, one that came up about 3 years ago. What is the impact of having a subscription program? And this example is to give a bit of a flavor for what a data scientist might do. So 3 years ago, 3 or 4 years, I can't remember, a long time, we started thinking about having a subscription program. So this was what it looked like back at the time of this work. Was you would pay $7.99 a month, and that would get you free delivery on all orders. There was no minimum spend, and you can cancel that subscription at any time. And the business is launching this, hoping that we will be able to better retain some of our customers. It will make it easier for people to order. And it will increase the frequency at which they order. So at the time that I joined the team, what had happened was we had launched a subscription program in some market. We had advertised it, and we had seen a bunch of people sign up to Plus. And we now want to know what behavioral change has that Plus subscription program had on these customers? And is it a good thing? Is it a good thing for the customers? And is it a good thing for the business? So what we attempted to do was to what we call a lookalikes methodology, to try and understand the difference between people that signed up to Plus and people that didn't. And we decided to compare, before people signed up to Plus, we decided to compare, find comparable people to those Plus subscribers on the basis of three things, and a few more, but these were the three main things. One was, how long have they been a Deliveroo customer for before they signed up? The second was, how frequently do they shop, and how much do they typically spend on an average order? So we wanted to make sure that these people were as comparable as possible before we introduced the Plus program, so that when we look at their behavior after joining the Plus program, we have some confidence that it is the Plus program that has driven the difference and not inherent differences in those customers that already existed. So then we can organize our customers into something like this, where we might have 4 people on Plus, 4 people not on Plus, and we think, you looked like very similar shoppers before these 4 of you decided to sign up to Plus. But what's the problem with this methodology, right? The problem is that these people that signed up to Plus, there is an inherent selection bias within them. These people signed up to Plus for a reason. They are inherently different from these lookalikes that we've chosen for some reason that we can't quantify. And so there's an unquantifiable bias in this group of people that have signed up to Plus. So what would we have done in an ideal world? In an ideal world, we would have run this as an experiment. Perhaps we would break out our customers into 2 groups, and we would show half of those customers an app with the option to sign up to Plus, and half of them the Deliveroo app as it is today, with no option to sign up to a subscription program, and then trade off the difference between those 2 approaches to try and understand for the business what is the most important. So lookalikes, for example, we can get a direct comparison between Plus customers and non-Plus customers. We can say these people on Plus are making 2 times as many orders as these comparable people on non-Plus. And we can do that right now because we've launched the program and we have the data. However, we know there is an unquantifiable selection bias in there. With an experiment, we're comparing between a world where a Plus program exists and a world where Plus doesn't exist. So we're not going to necessarily say Plus people do 2 times as many orders compared to non-Plus, but we can say in a world with a Plus program, the business achieves X many more orders or X% higher profit if the program is working, right? And so we would achieve better statistical rigor because these people have never been shown Plus that we're comparing to. But a negative of this would be that we can't do above the line marketing. We can't shout about Plus because half of our audience are not going to be able to see it. It's only going to be visible to them in the app. So at the end of the day, what we decided to do was to run an experiment. So we held some customers in a control group while we tried to learn what the impact of the Plus program was. And then we could visualize some really nice data like this, right? So we can look at, on the left here, I've got average orders placed by people who are exposed to Plus versus people in the control group. And you can see after 5 months, there is a clear gap here between those 2 groups. So this is implying that amongst that group that have been able to sign up to Plus, the people who have signed up to Plus have placed enough extra orders that it's actually driven up the average number of orders in that whole group, because not everybody in that group is going to sign up to Plus. So this is a really good sign that the Plus program was doing a good job of driving up order frequency and better retaining customers. And then on the right-hand side, you can see the other thing that we really cared about at the time, profit. We want to know whether driving those extra orders is profitable to the business or not. And bear in mind, this was 4 years ago. At the time, people exposed to Plus were not necessarily as profitable as people in the control, because if an order on an individual basis is not profitable, then having someone place more and more orders is going to make that less and less profitable over time. So what this highlighted to us was that there was something wrong with the way that we had set up the program, that it wasn't driving as much profit as we would expect. And so what we ended up doing was introducing a minimum order value on our orders. So if you sign up to the Plus program, we would ask that to get that free delivery, you spend at least X pounds on the order. So the impact of this piece of work was keeping the Plus program going. We showed like it's a good thing for driving orders, but we just need to make some tweaks to how to make it sustainable growth for us. It built stakeholder trust because we could show that we had some stakeholders that weren't necessarily trusting the lookalikes methodology, and so we can say, well, we've tried this other methodology and we're getting good signals from both. Expanded into more markets and tested new features like this minimum order value. And then the last example I wanted to talk about, so more along the machine learning lines, is how should we sort the restaurants on home feed? So by home feed, this is what I'm talking about. This is the page where we show you restaurants that we hope are most relevant to you. Again, what kind of data do we have here? So I've just pulled some from 24th of October here. For each session that we have on that app and each restaurant ID, we can see all sorts of things about how that restaurant presented to the user at the time. So we can see the price category. We have little pound signs that show how expensive that restaurant might be. We have restaurant ratings. So this is when customers leave ratings, like lots of other websites do. We calculate a percentage rating that we then show. We have the ETA, delivery fee, and then we have a flag here. Was this restaurant, did this session convert at this restaurant, yes or no? So you can see on this page, for example, if we look at EatFan, you can see the rating there of 4.8. You can see the price rating, it has £2 price rating. You can see the ETA is 15 to 30 minutes. And you can see lots of other things here actually that might make this particular restaurant more or less appealing to one individual than another. You can see that it has a meal deals tag, it has an only on Deliveroo tag, so it's exclusive to Deliveroo. You can't order from this at other places. It has over 500 plus favorites, meaning that more than 500 people have favorited that restaurant. So these are all small signals that people will be looking at to decide whether or not they want to order from that restaurant. And these are all things that we track so that we can help to make the experience as relevant as possible. So what might we start with if we were just given this blanket, a blank slate, and say 300 restaurants to sort for a user? We might just start with some simple exploratory analysis to understand what restaurant features are correlated with conversion. So a couple of examples here. On the left, you've got restaurant rating, and you can see a clear positive trend there. And then on the right, you've got estimated order duration. And you can see somewhat of a trend. You can see here at the lower end of estimated order duration, conversion definitely seems higher, and then it seems to get less important over time. Less important as the EOD gets higher. And so this is actually one of the first approaches we ever took years and years ago. We just sorted the list by order duration because we thought speed is probably what matters most to people right now. And then over time, we improve on that approach as we learn more and more about our customers. So one of the next steps that we took was to use machine learning, to use an algorithm to predict for us which restaurants is a user likely to order from. And here I'm just talking about new users, so people for whom we don't have any search or order history. And we could make quite, from this exploratory analysis, we could make quite a good approximation that the probability of a user purchasing from a restaurant is probably a function of several things, including some of these examples here. So popularity, how popular is that restaurant in your area? Do lots of people already order from there? Estimated order duration, so how quickly can it be delivered to you? What's its rating? What's its price? And does it have photos? Like photos were, we thought, would be a really important thing to make that visual element to make somebody order, to help somebody order and make a decision. So we ran a logistic regression, was one of our first approaches here. And we found that popularity was actually one of the most important features. So the recent order volume to that restaurant was really, really important in determining whether or not somebody would order from there. And then some of our other important features were what the minimum order value was, how long it would take to deliver, and price. And then interestingly, some of the lesser important features were the rating that was displayed and whether the restaurant showed an image on its original card. So what was the impact of this work? Well, each time that we have shipped an update to our algorithms which sort the home feed, we're aiming usually to deliver incremental orders, but also longer term impact, lifetime value, and business, commercial metrics like revenue. We're making it more relevant to customers, and that we can see by looking at how customers actually interact with the product and whereabouts in the list they order from. We make an assumption that if a customer is ordering from restaurants that are higher up the list, that we have done a better job at getting the most relevant restaurants to them at the top of the list than if they were to order from further down, just as an example. But I also wanted to note here that there was always opportunity to develop further, right? Like this was just a high level example from a few years ago of how we did it. Now we take into account profitability. We use different types of algorithm for our existing customers versus our new customers, because with our existing customers, we know more about them. And so it opened up that those possibilities and started our stakeholders and our science teams asking more questions as to, well, how can we improve on this? What if we included this feature? What if we did it differently for this group of customers versus this group? So those are my 3 examples. And then I just thought, this is my last slide, I just thought I'd include my top takeaways from 10 plus years in data and science jobs. These are things that I find are always coming back up and up in all of my roles with all of my teams. Correlation does not equal causation. That's something that I think we are always having to be mindful of and make sure our stakeholders are aware of. That just because you see a line going up on a graph doesn't necessarily mean that that particular variable has caused that. So a good example would be looking at conversion going up with the number of restaurants that you have available to you. That could well be that more restaurants equals more conversion, but it could also be that the mix of restaurants that you are showing is entirely different at a higher, when you have a higher number than a lower number. So always being mindful of that and helping people to make decisions with that in mind, that it could be correlation, but it could also, and also if we want to learn about causation, then we probably have to use some statistical techniques or run an experiment. Secondly would be to take incremental steps, and it ties in with the 4th point, really, that keep it simple. If we've got a business problem to solve, what is the simplest next action that we could take to learn, and then build on that over time. And the 3rd one here, experiments are great if you learn from them. So an experiment takes a lot of can take quite a lot of resource, a lot of people's time. They can be costly as well. So if you've released a feature that's really, really good for customers and you're holding it back from half of those customers for a month, for example, to test it, that can be costing you quite a lot of, that can be costing you and the business quite a lot. So I think the only experiment that is not great is an experiment that you've failed to learn from. So even if you have a flat result, for example, if you see that there's no difference between your feature and control group, if you can learn something from that and try to understand why, then that's not necessarily a failed test. Or if you see a flat result, but your goal was to not do any harm to a group of customers when you're releasing something new, that's great, and you can still learn. You've still learned from that experiment that you haven't done any harm to those customers. So that's my whole presentation. Thank you very much, everyone, for your time. Really appreciate it. We've got 20 minutes left, so yeah, I'm open to questions if anybody has any. All good? All right. Well, I hope that's been insightful for everyone.
I think
Oh,
Lila.
Yeah, sorry. Hi.
all right.
Right. I know, thank you for that presentation. It's really insightful. I understand that dependent on the organization that you work for, in terms of data science, data analyst, data engineering, sometimes they overlap. So how would you know in terms of if, you know, for example, I've gone for a specific role, say, for example, data engineering, you know, if I wanted to kind of like upskill to data science, what would you suggest in terms of, you know, making sure that I'm confident, I feel confident in that role?
Yeah, great question. And yes, they do. These disciplines do often overlap. And actually at Deliveroo, we used to have a value at Deliveroo that we never say it's not my job, which meant that our roles overlapped quite a lot, because that meant that we were asking people to be flexible and to flex into science or analytics or engineering as and when was needed to complete some tasks. So yes, they do overlap. I think a great thing to do, first of all, discuss with the business that you're in, discuss with the recruiters that you're speaking to, if you're looking for work, how flexible that business is in terms of your role. Would your role have a very set description, for example, and like these are the tasks that you complete, or do they have a bit of that flexible value in them where they do value people that are able to work across different areas? And then if you're in a role where you are able to work with people in the discipline that you're interested in upskilling, have a mentor, speak to them, be curious, ask questions, read their work, read their outputs, and see if you can work together with them on some project. So, for example, you might see something in your area that feels like it could be relevant to somebody in data science, or could do with someone from data science being aware of it. That's quite often the case in data engineering, is that scientists are going to use the data that comes out of a data engineer's work. And so having them aware of that and having their input on what you do, I think it goes both ways. It would be valuable for them as well.
Okay, thank you.
Oh, we've got some in chat.
Yeah, Sarah Solomon has asked, do you ever look at Google Analytics as part of your job?
I don't. I never do, and I never have. In about 12 years, I think I've logged into Google Analytics maybe once. I think there are people in the business that do look at that, but we're quite lucky at Deliveroo that we've been able to track a lot of the data ourselves. So we're able to see a lot of that internally. That's not to say that's not a useful skill to have at other businesses. I'm sure that it is, and I'm sure there are lots of people that that are still looking at Google Analytics in their teams as well.
Great. Another question is, what does your day-to-day look like as a data scientist?
Oh, interesting.
Day.
Yeah. So I'm a manager now. So my day-to-day looks very different from now from when I was a data scientist, but I can maybe give you a flavor of both. So as a data scientist, my day would usually start with a stand up with my product team. So I would work directly with my product manager and engineers, designers, user researchers, and we're all focused on some product area. So say our team we have a home and menus team, for example. So we're responsible for everything on the home feed and the menus page. We decide what our priorities are. We'd work in sprints. So over a 2-week period, we'd say, here are the things that we want to achieve. Here is the feature we want to ship. And then as a data scientist, it would be my responsibility to help them understand, for example, how are we going to understand the impact of a new feature? How do we design that experiment? How long should we run it for? What extra tracking might we need on our data to be able to answer questions afterwards? And then I would have ended up spending quite a bit of time coding and querying the data, but also working with my stakeholders to decide on approach and next steps. And as a manager, my role looks very different now. So my role is more about helping data scientists, analysts, and machine learning engineers in my team to focus on the right things and to unblock themselves. I think there's 3 things as a manager that are really important. The first is making sure that everyone in your team is okay, right? Like is happy, is enjoying their role and is able to perform at their best. Secondly, everybody has the right tools to do the job. And thirdly, that we have that business focus on the right areas so they're able to drive the most impact.
Isabel has asked, do you need different qualifications to move in the different data and science roles discussed?
Yeah, at Deliveroo, we definitely see it that way. So we would expect a machine learning engineer to have some different skills from a data analyst, for example. So a machine learning engineer would, at Deliveroo, they productionize models. So they need to have some software engineering experience. Similarly, a data scientist, we would expect to have causal inference skills. So they are perhaps have more statistical qualifications than, say, a data analyst. That's not always the case. Like I don't like putting people into boxes like that, because sometimes we have data analysts who, they know the data science work, they know the statistics, but they just enjoy doing data analytics work. So I think short answer, yes, there are different qualifications, but at Deliveroo, at least, we like people to flex as well. And I am a strong believer that you can learn some of those things on the job.
Yeah, I think also a follow-up question would be sort of for data science and analyst roles, sorry, what maths background or level of maths is needed? Asked by Stephanie.
Yeah, good question. We have a broad range at Deliveroo. We have people who have come in with maths degree right the way through to people who have a PhD. I'd say for science and analyst roles, having a degree in maths or physics or some STEM subject is usually really, really helpful, but it shouldn't be, I don't believe that should be a blocker. We've actually started some internships this week at Deliveroo with I don't actually know the level of qualification that our interns have right now, but I think up to A level should be fine in a lot of instances. And again, I really believe that you can learn on the job. But if you're able to get a degree in a STEM subject, that's always going to be really helpful.
Mm-hmm. Gemma has asked, which role did you enjoy the most, analytics, science, or machine learning, and why?
I really loved science because I really liked the cleanliness, what felt like running very clean experiments where you could quite confidently say afterwards, this is the impact that we believe it's had, obviously within some confidence intervals. But I really liked that because I could also see the changes that we were making in product as a result. But I've enjoyed all of them, honestly.
Yeah. Marie has asked, what type of skills are key in terms of making these changes and being competent in your team?
What type of skills are key? Yeah, so I think it differs for each of the disciplines, but there's a level of some of the skills. Let's talk about some of the specific skills then. So there's things like coding. So being able to write in a coding language such as Python, SQL, R. If you can write in one coding language, that's quite a transferable skill that you should be able to then pick up other languages quite quickly. That helps you to interrogate data sets, but also to build statistical models. Then there's kind of analytical thinking, analytical skills. So looking at a data set with the right mindset, that you're able to ask the right questions and think logically and incrementally through a problem to understand what steps are you going to take to get to the answer. Communication is a big one as well. So being able to communicate well with your stakeholders, not only to try to understand the problems that you're trying to solve and have a really clear objective or a really clear business question that you're trying to answer, but also in how you are then able to communicate your results with those individuals and land the message and drive action from what you found. And then the other four things I'd noted on that slide, so things like bias to simplicity and trade-off, speed accuracy trade-off.
Yeah. Yeah, sort of similar question from Kinde. Do you need experience with programming to get into data science? Or is that sort of like, obviously you were talking about learning on the job and things like that. Is it sort of required from the start, or is it something been sort of developed whilst on the job?
Yeah, this will vary company to company. It will definitely be a preferred skill if you have had programming experience. It's definitely going to help you get into a role in data science. So I would always advocate, if you can get any programming experience, do it, even if that's from doing some going on Kaggle and taking part in some challenges there, or just learning online, like SQL Zoo, for example. Definitely a great skill to be able to show that you have to get into data science. Whether there are companies out there taking on people without that experience, I'm not so sure, but at Deliveroo we definitely look for some level of that.
Yeah. Stephanie has asked, what transferable skills will be needed to be a data analyst without having experience? So what the sort of key skills?
Yeah, I think you want to show maths, that you've got some maths or physics or logic. The reason we would ask for a STEM subject like that, to some level, like GCSE or A level, is to show that logic. It's the way of thinking through a problem. Things like experience with Excel or Google Sheets are also great to have for an entry level position.
Yeah. I believe last question, but of course, if anyone else has some questions to ask, we have Lois here. Lela asks, we got another one. Second to last, potentially. What programming language would you say is the most useful as a data scientist? Obviously, you said Python, but is that sort of the most, or would you say there's anything else that yeah would be useful for that?
I can only speak from my own experience. I think if you ask different leaders at Deliveroo, they would have different answers here. I think SQL. I think SQL is an incredibly important language. Like, that is how we query our raw database. And I think you can go a long way with SQL. I am no expert in Python. And I've been here for 6 years. So I think Python is brilliant, especially if you want to get into machine learning or data science. That is a great one to learn, because that is what all of our machine learning engineers here use, and it's how they actually productionize models. But SQL is also a great place to start.
Oh yeah. And another question is, what is the predominant skill you see lacking from candidates for entry-level data analyst roles? What is the greatest challenge most data analysts find in their first year? And that's asked by Neviat.
This is a great question. And one I'm not sure I can answer very well, because I haven't interviewed for entry-level data analyst roles for over a year. I've been off having a baby. So I don't know. I'd rather say I don't know than give you a wrong answer there, I think. But I can say, I could maybe talk about what challenges people have when joining Deliveroo. What I typically see is usually the biggest ones are the speed accuracy trade-off. So knowing what's the appropriate method to use for that problem, like how quickly do we need to get to an answer, and what's the right way to approach a problem. So say you're given a business question like, why has our conversion rate from this customer group gone down by 10%? And think through that problem in terms of, if you had to answer that question today versus if you had a week to answer the question versus if you had a month to answer the question, what are the different methods that you might use in those 3 examples? I think that's a difficult one for people. And honestly, context switching, I think, can be difficult. Just something I hear from people is that when you're working across lots of different products or different teams, being able to switch your brain into a different problem or different area, typically people have found hard. And I think that's something that just comes with time and experience, and being able to better protect your time and organize your time so that you are able to have those periods of focus. That's something I hear the ICs in my team saying, is that they need hours at a time of focus. I don't know if you've seen, I don't know where it came from, but I read that if you are disrupted, if you're in focus on something and you're disrupted, it can take you 20 minutes to then get back into that. That's a big chunk of your working day. Yeah, so I hope that's still somewhat helpful.
Yeah, definitely. I think it's good to have insight on those early days within working in any sort of sector anyway. So I hope that did answer a part of your question, at least, Neviat. But I think, yeah, if anyone does have any burning questions, please, this is the time to ask, as I think we're going to be closing off. It's getting to 2 p.m.
Yeah, and please do, you can find me on LinkedIn as well if you'd like to chat anytime. Very open to speaking to anyone. And yeah, thank you so much for your time. It's been lovely to hear all your questions.
Yeah, definitely. Even I personally think it's interesting because I haven't really delved into data science, etc., too much. So definitely a great talk, and I appreciate everyone for coming out. Please do email us at academy@codingblackfemales.com if you have any questions about the talk, how to get in contact with Lois. We can send things over to you, so please do message us. And of course, in 2 days' time, we have our careers fair that's happening at Peckham Levels. Please do come out if you can. I'm always getting sort of updates every day about whether it's like sold out or there's new tickets on, but there seems to be quite a lot of people that are going to be turning up there. So please do come out. Yeah, just meet with the community and learn more from each other and learn from the people there. That'd be great. But thank you so much for everything, Lois, and thank you for everyone again coming out. I think we're going to stop it there and have a great afternoon, everyone. Goodbye.
Bye.